Alright, so today, we're doing a video on my next printer here, and this one is called the CKG PW 110CX. And I know that is a strange name. I'll kind of explain it later on. Before we really get started though, two things I want to mention right off the beginning is the camera is really weirdly mounted right now. So sorry you can't really see any of the print. Like I just couldn't get it mounted in a way that I really wanted it to. You also notice the spool holder is like really dumb, and it looks really bad. It does have a real spool holder, which was originally mounted to this little piece of plastic here that was held on with two screws at the top and a zip tie. Unfortunately, as I was getting out the printer to make this video, that snapped off, and I didn't have time to reprint a new one because I just wanted to record the video. So I just threw this together in a couple minutes. It was just some pieces of scrap wood. It's not good, but it holds the spool. Um, I'll probably reprint the real one at some point in time though. So why was this video late? Because I posted, I think it was over a month ago by now. I had posted that um, I had planned to record the video, but unfortunately it was pushed back because a part broke. And that part was the barrel jack connector on the power supply side. And this power supply is a mess. I think it's 12 volt. I think it's 120 watt, 10 amp. It's barely enough to run this printer. Like the screen kind of dims when you go to heat it up. It does work, but just barely. And the barrel jack, I think the one you can see it's working now. I think this is the fourth one I've had to put together with soldering it and doing all that stuff. I started it a little bit differently this time, so I could actually get the little like protective sleeve or whatever actually onto it. So hopefully this one won't break. But yeah, the other one broke, and I had to order a new one and solder it and get it all working. It's working right now. I don't think it'll break, but yeah, it's good for now. So that's why this video was really late. So I guess like some specs of the printer. You can see, and this is kind of the main like feature of the printer. As you can see, it's fairly small, and this whole frame here is actually 3D printed itself. So there's kind of a top gantry, and that's where the linear rods and the X and Y axis assembly is all mounted. And then that has, I think it was 8 screws that hold it to the main frame here. That main frame was actually printed in one piece on an Ender 3 Pro. That piece just barely worked on the 3 Pro. I had to really stretch it, but it worked. And then that top piece was also on the 3 Pro. And then most of the other pieces were either printed on the Ender 3 V3 SE, which is a printer that I also have. And then I think a couple of them were printed on my Select Mini, which as of right now is not working properly. Maybe I'll do a video on fixing that sometime. But yeah, the mainframe is printed. This is what I was kind of trying to achieve with my last one from the last video. But I think I went too far with that one. You can't really have printed lead screws in rails that work particularly well. And this one works decently well. I have used it before. I have used it for real projects. It does work. Quality is alright. We'll get to that later though. So the Hotend, just like the last printer, it's just the standard Creality Mark 8 Hotend. Nothing really too special about it. So there's a couple problems with the Hotend, as well as this fan duct and the X carriage. So the fan duct is really it's really stupid. So on the front, I think it's a 30mm fan cooling the Hotend, and then the main blower fan, I think it's a 5015, that blows through this very poorly designed, very weak duct. And I had to get it kind of compact. That's why I used a small fan, and that's why the 5015 is all the way at the top, because I didn't have enough space, or I didn't have a lot of space on the sides or at the front. So I had to make it like really tight and compact, and it ended up working. It doesn't look particularly great. It doesn't work particularly great. It's not very sturdy, and it only cools from one side, and the Hotend heatsink probably gets hotter than it should, which is where we lead to the X carriage. So the X carriage, the Hotend is attached to it by two M3 screws, and those M3 screws like to heat up because the fan on the front is really small and weak and underpowered, and the duct isn't designed very well, so it just doesn't get cooled properly. So sometimes those screws will heat up, and they'll kind of like, they won't fully melt out of the X carriage, but they'll get a little looser than they should. So that's not great, and I have eventually I don't want to reveal too much about this printer, but I plan to have it a full metal X carriage, which will be pretty cool. So the motors I'm using on, I guess a CoreXY doesn't really have a specific X and Y motor. So the two motors at the back, we'll call it, they are both NEMA 14s as well as the Z motor. So I use a cantilever design. It works well enough. We'll get into that later because it has some issues. The NEMA 14s actually really surprised me. I've heard that they're not very good. They don't have a lot of torque. They don't have a huge amount of torque. They're definitely noticeably weaker than NEMA 17s, but they work more than well enough for this. Um, and the NEMA 17, I actually have a NEMA 17 for my extruder motor, because that one needs a fair amount of torque, and I had a NEMA 17 laying around, so I might as well use it. So something that you may or may not have noticed is that I pre-recorded this video, and me speaking here is actually a voiceover, and that's because this printer is very loud. I did the last video like live, I guess, because I mean, first of all, the printer wasn't printing, and it was quieter. It was just a quieter environment. This printer, and I'll play the audio for a second. You can see it's quite loud, and that's because I'm just using A4988 stepper drivers. They're cheap, but they're not quiet. The wiring, you also notice on the side here, is really bad. It's a little bit better than the last one because it actually put some amount of effort into it. It wasn't a lot of effort for this one, but there was effort that was put in. And it's just a mess. I don't have a proper electronics enclosure. It's just kind of the motherboard is screwed onto a plate, which is just screwed onto the side. And then just every wire goes to it, and they're all everywhere. It's a mess. It's just held together by zip ties, most of it. So onto the bed assembly. So it's a cantilever design. It works okay. I think for this small of a printer it works, but any bigger, I would want to go with dual lead screws with it's supported on both sides. Dual supported is what I was trying to say, which would work better. And just be more secure. But this is okay enough. It also has a 3-point leveling system, which works decently. It's pretty easy to level. I find that the front left and right corners can sometimes be messed up, so I probably won't ever use a 3-point system in the future because the 4-point works well enough for me. Some more about the bed. So both parts of the bed are actually CNC machined out of particle board. So I did some shorts a while ago of CNC parts for a 3D printer. Those are on the 3018 Pro. There'll be a video on that eventually. That won't be for a while. Because I plan to do a bunch of upgrades for that. But anyway, those were made out of, I think it was 5/8 particle board. I chose to CNC them because, well, the bed itself, which has the tape on it, couldn't be plastic because stuff would just melt to it. But I chose to make the bed frame out of particle board because I feel like 3D printing it wouldn't be really efficient, because I really wanted the bed frame, especially because it's a cantilever design, I really wanted the bed frame to be really nice and stiff. So that's why I printed it out of really thick particle board, or CNC'd it out of really thick particle board, and it is very solid. It's very stiff, and it's big and flat. So even if it didn't need to be solid, I probably would have CNC machined it anyway, because it's just not an efficiently designed part for 3D printing, because it wasn't designed for 3D printing. It was designed for CNC. So the CoreXY, I've chosen an unconventional design, because I have another printer coming up, which will be probably my next video. It's actually done right now. It's actually actively printing as I'm speaking. It works very well. I've done a couple shorts on it as well. It's the one made of the aluminum extrusion. That has a traditional CoreXY design. This one does not. This one uses a very weird design. I guess it's nothing's weird about it other than the fact that it's just uncommon. So you'll notice the front two pulleys on the front left and front right are both stacked vertically, so there's no offsets or anything, as well or as the ones on the like the Y carriages are both stacked vertically, and then the steppers on the back are actually offset to the side. Um, this CoreXY works well. I don't really know why it's not more commonly used. It does look a little bit dumb with the belts kind of like diagonal like that. The belts aren't stretched at all though, like the tension doesn't change, so it's efficient, I guess. Um, Another problem with the belts is that they're really loose, like way looser than they should be, especially because on a CoreXY, having proper belt tension is really important. That's a big issue here because the reason I can't tension them very much is because these motor mounts in the back here, they're thin and 3D printed with low infill in walls, and they're only secured to the frame with 2 screws, which makes them really flexible, and weak and bendy, and they're just not good. So I can't tension the belts enough without pulling the motors off their mounts. So it should be way tighter. It's just how it is. So let's go. Let's talk about the naming scheme because it's kind of weird. So this is the naming scheme I'll probably be using for my printers going forward. It's not great, but the way it works is CKG is the name of this channel. CKG actually stands for Civil King Gaming, which was the old name for my main channel, which I have since changed the name to Civil 35. And I just went with CKG for this channel because it tied into my main channel. The PW stands for Plastic Writer, and the reason I called it that is because if you notice my channel logo, the colors, it's not an actual rainbow. It's arranged in the way that the like 1980s Apple logo was, and I just like Apple and their stuff. I think it's cool. And they had back in the 80s, I think 70s even, maybe 70s, for sure 80s and 90s. They had a series of normal paper printers, and they had the image writer, the style writer, and the laser writer, and those were printers. So I thought I would call it plastic writer because it is a printer. So it has the writer in it, and it prints with plastic, so that's kind of cool. And then the 110 just stands for 110 millimeters on the X and Y. That's pretty basic. And then the CX stands for CoreXY. I'll probably just change it to CKG PW 110X. I just think that'd be a little bit better. So that's the naming scheme. It's a little bit messy, but it does make sense. It has an actual scheme to it. I'm not just making up numbers like K1 or X1, but it does at least have a consistent enough scheme. So about print quality, it's fairly decent, especially for how loose the belts were and for a printed frame. I'll put some pictures up on screen. This is actually of the print you're watching right now. It has since finished as I'm recording this part now. I don't know why I printed it in black because you can't really see it well then. Because I had to get the lighting weird. It's an okay print. It's not the best, but it's dimensionally accurate mostly, and it's passable. It's decent. That's gonna be about it for this printer actually. For the next printer though, that video should be out soon-ish. And like I said, it has aluminum extrusion. It's also a CoreXY. I've done some shorts about it, and it's really good. It's a lot faster than this one. It's just a lot better in general. But for this video on this printer, that's gonna be it. So I hope you enjoyed it, and I will see you in my next video.